Okay, so we started talking last week about these complex where you have so complex numbers are typically in this form where you have some real number and then some imaginary number. Okay, and we talked about how I is just the square root of -1. So just to recap, if you wanted to do like the square root of -49, without using imaginary numbers, you would have no real solution to this, but using imaginary numbers, we can split that up into the square root of 49 and the square root of -1. So I end up getting 7, and then the square root of -1 is just replaced by I. Okay, so that's what we had done last week. And then we just started touching a little bit on, say I wanted to do, some operations with these complex numbers. So for example, if I wanted to add together 2 plus 3i plus, 4 minus 6i. So here's two complex numbers and I want to add them together. First, let me ask you, these parentheses here, do they really mean anything? No, they don't, because they do. I mean, it's just saying here's one number and I'm going to add this other number to it. If I got rid of the parentheses, mathematically it's going to be exactly the same. That would not be the case if that was a minus sign, because I would have to subtract this whole second binomial. Okay, we'll do an example of that in a minute. But if it's addition, you really don't need those parentheses at all. So it's the same thing as doing 2 plus 3i plus 4 minus 6i. And then you're going to treat I exactly like a variable. So in other words, I can only combine like terms. So I can only put these two guys together, the ones that are both have the i's on them, and I can put these two together, my two normal numbers. The only difference is that if those were an x, for example, my answer would be -3x plus 6. We put the x term first. Since I really stands for a square root, though, we put it at the end. So you want to add your real numbers first, so that would be 6, and then -3i would go at the end. Okay, so that's the only difference, but you do combine like terms just like you would if that was any other variable. Okay, so let's try a subtraction one. Let's say I wanted to do, 1 plus I minus 4 minus 7i. Okay, so here's example 1, example 2. Here, the parentheses, I'm more concerned about them because I'm taking this number and I'm subtracting this entire number from it. Right? So what I really have to do is I have to distribute that negative to both of these. So often kids don't do that and they only subtract the 4 and they never subtract this. But as you can see, I'm subtracting the whole thing. So what I like to do is I like to rewrite it 1 plus I, distributing that negative, minus 4 plus 7i. And now I can just combine like terms. Okay, but you have to distribute that negative, otherwise you're going to get it wrong every time. So again, I just would combine my real numbers together. So 1 and -4 is a -3. And then positive I plus 7i would get me positive 8i. And the same thing goes, we don't have to put the 1 in front of the I, just like if it was an x. You don't have to put the 1 there. You can, doesn't matter. But there's your final answer. Okay. Let's try some multiplication. What if I did something like, say I want to multiply two complex numbers together. So 6 minus 3i times 2 minus, 4i. If you were going to multiply these two things together, what are you really doing? Foil, yes. You have a binomial and a binomial. Please take a moment and foil those two together. See what comes out. How'd you do? You got a final answer? So be careful when we're foiling. First, 12, right? Outside, minus 24i. Inside, minus 6i. And then the last is going to be a positive 12i squared. Did everybody get that line as it is? Okay, now I just have to combine like terms, right? So 12, there's no other normal number, so I'll have 12 minus 24 and a minus 6i become a negative 30i. But then we talked last week about I squared is not really, well, it is I squared, but it turns into negative 1. Right? Because the square root of negative 1 times the square root of negative 1 just becomes negative 1. So this chunk is actually 12 times negative 1 or negative 12. And now I can combine it with the 12 out in front. So it just so happens that 12 plus negative 12 cancels each other out. That won't always happen, but it did this time. So my final answer would just be negative 30i to this. Do you see that? So anytime you see an I squared, you have to go in and change it to a negative 1. Same thing with I of any power other than to the first, right? If it was I to the third, right, you could change that to be negative I, and I to the fourth, you know, turns into 1. Okay, so if it's I to the first, there's nothing to do, you just leave it as I squared becomes negative 1, I to the third is negative I to the fourth always goes back to 1. Okay, so there is your final answer for that one. Okay, let me try and trick you. What if you had, oh, I don't know, 5 minus 4i squared. Oh, sorry, like that. Bless you. I hope you didn't fall in the trap. Oh my gosh. But if you fell in, it's your own fault. I told you I was trying to trick you. You gotta stay sharp. So, the trap that I hope you did not fall into, you cannot just square the 5 and square the negative 4i. It doesn't work like that. Remember, this is a binomial times a binomial. You have to FOIL this together.
I would never even think about doing that.
Oh, you have to. Oh, okay, good. The only time that you can do that is if you only have one term in there. If there was all multiplication. Like, for example, if I had 2xy and I want to raise that to the third. That's all multiplication. Yes, everything in there will get pushed to the third. This is not that way. This is a binomial. You have to FOIL this together. If you don't, you're going to be missing that middle term. So you'll have some right pieces, but it's not the whole answer because you didn't do the entire number times the entire number. So first 25, outside minus 20i, inside another minus 20i, and then last would be a positive 16i squared. Okay, so if you didn't FOIL, you're going to not have this negative 40i in the middle, which you need. That's kind of a big deal. So I'd have 25 minus 40i, but then this turns into minus 16. And now I can combine these two. So that's going to be a positive 9. So I'd have 9 minus 40i as my final answer.
I got that.
Good. Please be careful. If you have a binomial squared, you have to FOIL it. Me, personally, I have to write it out. That's just the way my mind works. I can't even do it in my head. I might be able to if I was hard-pressed, but I like to write it out. I like to see it. I like to do first, outside, inside, last. Right? And then I know I'm doing it right. I know I didn't miss anything. Okay. So, So far, your i's work exactly like variables, except for when you have I squared, you just got to change it to the -1 and put the i's at the end. But otherwise, I mean, it's math that you've already seen. So let's talk about when you have an I in the denominator. Because remember, you are not allowed to leave square roots in the denominator. So let's say I gave you the number, oh, I don't know, 4/5i. And I told you your directions are to rationalize the denominator. Do you know what that even means? That means turn your denominator into a rational number. Rationalize the denominator. Yes. So if it was 4/5√3, don't you multiply by √3/√3? Right? To get rid of it? It's the same idea. So I'm going to multiply by I/I. I don't have to multiply by 5i, though. The 5 is fine. It's the I that's the problem. So when I do this, in my numerator, I'll have 4i. But what do I get in the denominator? 5i squared, which is just -5. Right.
Can't you not have a negative in the denominator?
Yeah, you can.
Yeah.
Negatives are fine. It's square roots and 0 that you can have. And, because couldn't I take a negative and move it upstairs if I wanted? You can, so. Same thing as -4i/5. Okay, so try this one for me real quick. What if you had like, I don't know, -3/6i. Simplify that one. Okay. Did anybody do anything before you started dealing with the i's? You can reduce the -3/6 if you wanted to. You don't have to. I mean, you can do it at the end. You have to do it at some point. But it doesn't matter if you do it in the beginning or the end. I'm going to do it in the beginning. What's -3/6?
1/2.
Yeah, it's going to turn into a positive 1/2 I. I still have to take care of this I. It doesn't matter if I do it, if you did the other way around, who cares? Our final answer should end up the same. So I have to get rid of this I, so I do what? Yes. And do you know why I'm multiplying by I/I? What is I/I really? 1. When you multiply something by 1, you're not changing its value, right? So I'm allowed to do this. So across the top, that's just I, and then downstairs it's going to be 2i squared, which is just -2. So if you want to, you could write this so many different ways. -1/2 I, and then the I. You could do -I/2, all the same, whatever you want. Okay, now get ready for this one. Hold on to your britches. What the heck are you going to do with this? I wonder if you remember. Should I tell you the wrong thing to do? Because I feel like you're doing it. The wrong thing to do is to multiply by I/I. Well, it's not wrong. It's just not going to get you anywhere. It's not going to get you anywhere because if you multiply this bottom thing by I, you're just moving the I from the 2 to the 3. You didn't get rid of it. You just moved it. And you didn't move it up. So multiplying by I/I is not going to work here. Thoughts? Do you remember what to do? You did do this before. Like if this was, 4/3 minus √2. Do you remember what to do for that? Because it's the same thing that you do here. No one remembers? Dig deep. Oh, you're so close.
It's a negative.
Yes, you got to multiply by what's called the conjugate. Do you remember that? So it's the same binomial, you just change the sign in the middle. Why? Why in the world would you bother changing the sign in the middle? Because, watch, when we FOIL the bottom, if you have a positive and negative, they're going to cancel out. So that's the magic. Okay, so I'm going to multiply top and bottom by the conjugate of this. And I'll write that in words in a minute. So I want to multiply by 3 plus 2i over 3 plus 2i, which is still 1, right? 3 plus 2i over 3 plus 2i is still 1. It's still the same thing on top and bottom. But when I do this magic, right, across the top I have to distribute. So you're going to get 12 plus 8i. And then downstairs you have to FOIL those two together. If you have done everything correctly, all the i's will cancel out when you're done with this on the denominator, right? You can have i's upstairs all day, but downstairs they're all going to cancel out. Watch. First, 9. I'll write it here. Outside plus 6i, and then inside minus 6i. That's why one has to be a plus and one has to be a minus. And then the last are going to be a minus 4i squared. If you don't have them as opposite signs, you're never going to have these two cancel in the middle, which is crucial. Now be careful. Be very, very careful, because you have negative 4 times I squared. So that chunk is really... What?
Oh, I thought you were talking about the 6 as well.
Yeah, this turns into a positive 4, because I squared is negative 1 times negative 4 is now a positive 4. So 9 plus 4, my denominator is actually now 13. Is that a final answer?
Yes.
It is, because there's no reducing, no other reducing that I could do. Okay, so yes, in this case this is a final answer, but I want to show you just...
That was a 4.
Right. Pretend for 1 second if I had gotten 12 plus 8i over 14 even. If all 3 of these numbers have a common factor, it has to be all 3 of them. You would have to reduce by that common factor. So pretend that this is the answer that you got. What goes into 12, 8, and 14? 2, so I'd have to reduce everybody by 2. So that would be 6 plus 4i over 7. In my case, it doesn't, because 12, 8, and 13, there's no common factor, so I'm done. But you have to look for that. If all 3, and it has to be all 3 have a common factor, you reduce by that common factor. Okay,